Hello, today's video is on section 6.4a, first order linear differential equations. So today we're going to just talk about how to solve first order linear differential equations, and then in 6.4b we are going to use linear differential equations to solve applied problems. I'm splitting it up over 2 days since it's election week. I thought we could use a little bit of a slowdown in pace. All right, so first order linear differential equations, what are they? Well, they're equations of the form dy dx plus p of x times y equals q of x, where both p and q are continuous functions of x. And when it's in this form, it's called standard form. So we always want to make sure that we write it in standard form so we can find something called the integrating factor. And so to solve these, we multiply both sides by the integrating factor. And what the integrating factor is it's this function we call u of x, and it's e to the integral of p of x dx. All right? So what happens is if I have my differential equation standard form, so y prime plus p of x y equals q of x, and I go through and I multiply both sides by e to the integral of px dx, I get y prime times e to that integral plus p of x y times e to the integral equals q of x times that integrating factor once again. Okay, this looks really gross, I'm sure, but if we examine this side a little bit closer, we see that we actually, in fact, have the chain rule, the product rule, right? So I have y and y prime as one of my factors, and then I have e to the integral of px dx, and chain rule gives me that this is the derivative of that, so I have chain rule here. So, not chain rule, excuse me, sorry, I keep saying that. Product rule, okay? So if I undo the product rule, I really just have y times e to the px dx, the derivative of that, right? And then my other side is q of x times e to the px dx. And then if I integrate both sides of that, I get something that looks like this. And so on the left-hand side, I'm just left with y times e to the integral of px dx. And on the right-hand side, I have the integral of q times x. And then remember, that's just the same thing as u of x dx. And then I'm going to go ahead and divide. So I get y equals. And so now I have e to the integral, remember that's u of x, so 1 over u of x times the integral of q of x, u of x dx, okay? And so this right here is my general solution. Let me give some more space here. Put it in a box. So this is the general solution. To my differential equation, which is dy dx plus p of x times y equals q of x, where u of x equals e to the integral of p of x dx. All right, that may seem a little confusing, but let's do an example and show how it works in action. So our first example is to find the general solution of y prime plus y equals e to the x. So the first thing to do is make sure it's in standard form. So we already have it in standard form. So when it's in standard form, I need to identify P and Q. So if I look at this, the thing that's multiplying to the y is P of x is just 1. And then the function by itself on the right-hand side is Q of x. Then the next thing I'm going to do is find the integrating factor. So my integrating factor is going to be e to the integral of P of x dx. So I get just, I get the integral of just dx. So my integrating factor is just e to the x. So then if I look at my general solution, I can go back to what we just proved. Is then going to be of the form 1 over u of x times the integral of q of x u of x dx. So I'm going to get 1 over e to the x. And then my integral of q of x was also e to the x, and u of x e to the x dx. So then I'm going to go ahead and simplify this. So if I simplify this, let's see here. If I integrate this, well, let's see, we can combine those e to the x's. So I get 1 over e to the x times e to the integral of e to the 2x dx. So go ahead and integrate that. You can do u substitution if you want, but we can see that we need to multiply by 1/2 e to the 2x plus c. Now make sure your plus c is in the parentheses because that 1 over e to the x is being multiplied to all of that. Then I'm going to go ahead and distribute that 1 over e to the x. So one of those will cancel in my first term. So I get 1/2 e to the x plus c times e to the negative x. Right? Or you can write it as c over e to the x. And that would be my general solution. All right. So there we have it. So y equals this is my general solution. And if they gave us an initial condition, we could go ahead and plug that in and find the value of c. Let's do one more example. Oh, right here. Here is the official solution to first order linear differential equations for you. So if we have y prime plus p of x, y equals q of x, and we have our integrating factor, we multiply and we can get the general solution is this. So there you go. There it is, all nice and fancy for you. Okay, next example. Next example is to go ahead and find the general solution of x, y prime minus 2y equals x squared, where x is greater than 0. So my first job is to go ahead and put this in standard form. So I'm just going to rewrite it first for myself. And then putting it in standard form, I'm going to go ahead and divide everything by x. So then I get y prime minus 2 over x times y equals x. And so then I see that p of x is going to equal negative 2 over x, and q of x is going to equal x. All right, so then my integrating factor is e to the integral of p of x dx. So then I get e to the negative 2 over x dx. And when I integrate that, I get e to the negative 2, natural log of x. And x is greater than 0, so I don't need the absolute value. And I'm going to go ahead and take that negative 2 in the inside, so I get the natural log of x to the negative 2. The e and the natural log will cancel, so I'm just going to get x to the negative 2, or 1 over x squared is my integrating factor. So then I'm going to go ahead and go through and multiply both sides of my standard form by 1 over x squared. So the standard form we had was y prime minus 2y over x equals x. And I multiply both sides by 1 over x squared. So now I get y prime over x squared minus 2y over x cubed equals 1 over x after I simplify. And so if I look at this once again, I can see that I have a product rule. So if I go through and I decompose that product rule, I can see that I have y times x to the negative 2. So if I rewrote this, so it might be a little easier to see if I rewrote this. So if I rewrote this as y prime times x to the negative 2 minus y times 2x to the negative 3 equals 1 over x, it's a little easier to see that I really have y times x to the negative 2. I have the derivative of that, and so that's using the product rule. So I really have y times x to the negative 2. Okay, so undo that product rule. This is going to be a trick you're going to need to do in your homework, all right? And on the other side, I have 1 over x. Go ahead and take the integral of both sides. Oops, I forgot the dx. So when I take the integral of both sides, I just get y times x to the negative 2 equals natural log of x plus c. Once again, we already know x is greater than 0, so I don't need that absolute value. And solve for y, so I get x squared times natural log of x plus c in parentheses. All right, so that is my general solution to that differential equation. And if they gave me an initial condition, I could go ahead and solve for c. Next class, we're going to talk about falling objects, filling containers,